All right. And here, or maybe this one first, Proppant. Okay, the Proppant, the information of Proppant is located within the fluid properties. Okay, and this is about the permeability of the Proppant pack. Okay, so before, yeah, if you really want to understand about hydraulic fracturing simulation, you need to first understand the hydraulic fracturing itself. And in hydraulic fracturing, we use Proppant, okay, to withhold the fracture, the open fracture, and to prevent the fracture from being closed again. Okay, and we know the Proppant, we know that the Proppant pack will have permeability. All right, and in this case, we have two Proppants, Proppant 0 and Proppant 1. Proppant 0 green color, Proppant 1 purple color, and this is the table showing us the permeability as a function of pressure. Okay, so in higher pressure, we are talking about hundreds bar here. The permeability becomes lower and lower, smaller and smaller for both Proppant. Okay, so this is the user interface, but if you want to create this kind of information within the keyword, you put that under the, props. And in this case, we have the information for Proppant in the relative permeability keyword on in relative permeability file. Okay, so after we have relative permeability, we can put the keyword, this one, n propans, okay, to tell tNavigator that we will have two package of propans. Okay, and the keyword Proppant names to tell tNavigator I have two Proppants and the names are Proppant 0 and Proppant 1. Okay, you mentioned the first Proppant first, Proppant 0, and the second Proppant, so that later when we create the Proppant table using this keyword Proppant table, the first column will be the pressure, and the pressure is presented in metric unit, bars, right? And the second column will be for the first Proppant, and the last column here, the third column will be for the second Proppant. Okay, and of course you put slash to close each of this keyword. So also slash there and slash for Proppant names, slash for n Proppants. Okay, so that's easy. Okay, if you want to use hydraulic fracturing, you put Proppants and give information about the Proppant on the keyword. All right. And then we also have another thing. I'm going to close it a little bit. Flow functions. So we also have flow function, two flow functions, each for each of the Proppant pack. Flow function 0, flow function 1. So what is flow function? So flow function tells the simulation that the Proppant or the fracture will not last forever. Okay, later on, the fracture will close again. Okay, and of course the productivity will be reduced again. Okay, so the performance will decline, not because of the pressure, but this is the inherent limitation that the fracture has. Okay, there is no permanent fracture actually in the world, so we want to represent that decline of the fracture performance by using flow function. And we have two types of flow function here. The first one is linear, okay, from the flow function 0, the first one, and exponential decay. This is the table, but it's actually generated from the correlation or the equation. So we are the one who put or who provide the correlation to tNavigator, and we give that in terms of, keyword. Again, we can put that under the props. Here in this case, they put under or in the same file as the relative permeability. So we have that flow func, the keyword flow func, each keyword flow func, each for the propan. Okay, so the first one, you give the information regarding the name flow func 0, that's the name. And then the second information is about whether it is linear or exponential. Okay, so flow func 0 will be linear. And regarding these two numbers, 0.99 and 1, I think you're going to need to read the manual. I'm not going to explain about that, but actually to express the either the line or the curve, you need two values. You need two numbers, the first number and the second number. Okay, and yeah, so to create this kind of line, you give two values, and the value is 0.997 and 1. And to create this exponentially decaying line, you use this one. Okay, I'm not going to explain about that. Yeah, it's a little bit mathematics there. So yeah, you can just go open the manual and read it for yourself. Okay, but actually we put this correlation, we put this equation on the file, and we put the keyword. Don't forget to close the flow func with slash and close this line with slash. Okay, and yeah, later the tNavigator will use this equation to generate this table. All right, so far so good. By the way, we have completed the equation or the running, so we can check the production.